Welcome to another lesson, and feel free to interact. So far we have done enough. We are on benzene, and we are on the reactions of benzene, where we saw that benzene undergoes electrophilic substitution reaction, and it doesn't undergo addition reactions, which opposes the Kekule's work. So today we talked about alkylation, we talked about halogenation of benzene, talked about sulfonation, nitration, and actually all those reactions, they are equally important as far as organic synthesis is concerned. They are so important as far as synthesis is concerned. Because I will say, synthesize this from this. For instance, I will say, synthesize maybe this so for instance, they can say synthesize this. You have a ring, and you have maybe OH, and they want you to convert the OH into maybe a benzoic acid. Okay, into a benzoic acid. So now, how are we going to do? What are you going to do about it? So do you see that the reactions of benzene become key? Okay, the reactions of benzene. So you need to know how to convert this to benzene. I want to do it, but by the time we finish, it's just like a food for thought. By the time we finish, okay, you should be in position to do. So you should know how to convert this to benzene.
Teacher, you have muted yourself.
So you need to know that reaction where you can convert the phenol into benzene, and then from phenol you find how you can form the benzoic acid from benzene, and it's none other than addition of a methyl group. Okay, so do you know how to add a methyl group on the benzene? Yes. If you do you know the mechanism of reaction that leads to addition of a methyl group on benzene? Yes. And then finally you oxidize this methyl group into a benzoic acid. Do you know the reagents? So it's just a food for thought. Okay, it's just a food for thought. Just think about it, so that by the end of today's lesson, probably, or in the next lesson, you should be in position to write all these mechanisms and all these syntheses. Okay, brilliant. So there's somebody in the chat box asked what acylation is. Acylation is simply the addition of an acyl group or an acyl group to a compound, okay, to form an aromatic ketone. An aromatic ketone, you're going to see. So an acyl group is, you have an alkyl group. Let me just generalize. You have an alkyl group, and then you have this carbonyl carbon, okay, but instead of the OH, or instead of the H, or instead of the C, another alkyl group, it is replaced by a halogen or an halogen, maybe Cl, maybe Br, maybe iodine. So this is an acyl group, okay, an acyl group. So using the same reaction as we did, we can add this acyl group. For instance, when you have your benzene, okay, you can react it with, so that's benzene. Like I told you, this is not how we write benzene, but because I'm writing with a touchpad, then it becomes hard to write that balanced structure. Okay, but all these sides must be equal. All these sides must be equal. So this one is going to be so you are reacting it with, or you want to add an acyl group. Okay, RO CH and then with a Cl. So this is the same Friedel-Crafts acylation. This one is going to be, you have your benzene ring, okay, and then you have the C, and then you have the O, and then you have the CH3. And so now this reaction is important in organic synthesis. For example, I'm going to give you some synthesis and you try it out so that you can appreciate. So now, so what are we going to do? We shall react the same, but now we shall need a halogen carrier. Okay, maybe aluminium chloride. Okay, aluminium chloride, maybe. So this is one, or you can use iron 3 chloride. Okay, any halogen chloride. Is that so? Sorry, any halogen carrier. And then you heat at 50 degrees Celsius. So if you do this, then you shall be in position to produce an aromatic ketone. Why a ketone? Because of this carbonyl carbon. Whereby this side it is surrounded by a methyl group, and this side is surrounded by an aryl group. So it is a ketone. Okay? It is a ketone. Let's see how this reaction is really important. I might give you this. Which one can I give you? Okay. My God, sorry. I'm looking for a pen and I can't use yellow in yellow. So I might give you this and I say synthesis, write equations to effect. And actually you're going to do it. Get your pens and do this. So you have the OH here, and I want you to prepare a secondary alcohol. Okay, a secondary alcohol. So I want you to prepare this. CH. Okay, and then you have the OH here, and then CH3. So can you do that? Please, chap, and I'll give you 0.3 marks. So can you give it a shot? Try it out. And we have studied all this, I think. We have studied all this. So I've seen your work and it's really, let me say, fair. So some of us did mechanisms, others. No, I want synthesis. Show different equations to effect how you can synthesize this, okay, from this. You have this, okay, but you want this. Which reactions are you going to use to reach your final product. So simply, you're going to convert this into benzene, and we are going to see the reactions. Okay, you're going to convert this into benzene, and then after converting into benzene, then you add an acyl group. What is the acyl group? And Jordan had the correct steps, but the reagents became berserk. And then you add an acyl group, which is C, okay, and then CH3. So this is an acyl group. Now after that, then you shall reduce this acyl group, this carbonyl carbon, to form an alcohol. Jordan had the steps, but the reagents had issues. So from this to this, and then from this to this, and then from this to this, just 3 steps, and you have the 3 marks. So now what are the conditions? So after knowing the steps, like I told you in synthesis, you look at what you want, and then you look at what you have. And then in your mind, you think about reactions that you are going to carry out to come up to what you want. Okay? Yes. So whereby, now if I produce to form this alcohol, I'll form it from this. But how am I going to form this from benzene? So can I convert this to benzene? Yes, I can. How? By heating it with zinc dust. Haven't you ever talked about this reaction? Preparation of benzene from phenol? Yes, we talked about it. Remember? I don't want you to forget. So zinc dust, okay? And then we heat. If you do this, you shall produce benzene from this, from phenol. We did this reaction in the preparation of benzene. Then we have just studied this reaction today. Which reaction? This one, the Friedel-Crafts acylation, where we shall add the CH3, okay, and then see an acyl group, okay, and then the Cl in presence of the iron 3 chloride as a halogen carrier. We shall form this, and then we heat up to 50 degrees Celsius. If you don't have the heat, then you are not marked. Okay, then we shall form this, and then from this, what should we do? We shall just reduce reduce this to apply to a secondary alcohol. And we have different reducing agents, but the common one is we shall use lithium aluminium hydride in presence of dry ether, and we do the heating, we do some heating. So don't you remember this reaction? Yes, and then we do some heating. So basically it is as simple as this, and you will have your secondary alcohol. You want to name? This is carbon 1, and then so it is going to be phenyl ether. Phenyl ether, because the ring is on carbon 1, the OH is on carbon 1, and this is, so it is just phenyl ether. This one is phenyl ethanone, and this is benzene, and then this is phenol. So now what is really hard? What's really hard? Let me give you another synthesis. You give it a shot, because I see. Yes, I'm going to give you another synthesis and you give it a shot. So any query as far as this is concerned? you can synthesize this. Now it's not that always you will use an acyl group or acylation. So you have maybe, what do we have? Okay, we haven't studied nitro. Okay, so let's say we have this. We have benzoic acid. Okay, benzoic acid, and this is O, and this one is also O. So we have benzoic acid, and we want to prepare okay, let me give you this reaction. Okay, and we want to prepare nitrobenzene. Nitrobenzene. All these reactions we have studied them. So how are we going to do it? We have studied all these reactions. And maybe another one, we have phenol, and we want to prepare, we have phenol, and we want to prepare ethyl chloride. So these are just simple chaps. These are just simple things. We want to prepare maybe, anyway, let me not give you what we haven't studied. And we want to prepare this. Can you do that, chap? Yeah, that was some good work. You did some good work. So from here we shall form benzene. Okay, we shall form benzene. I said I'm sorry for these structures, they are not good, but it's because I'm using a touchpad. So we shall form benzene, and so here what will be the reactants, what will be the conditions? Here we shall use the fused soda 9. So calcium oxide in presence of sodium hydroxide. Okay, and then so it's a mixture of calcium and sodium hydroxide, calcium oxide, and then we do some heating. We shall take off this group and remain with benzene. You remember this reaction even in alkanes, where you have CH3, CH. This reaction is important in synthesis that involve reduction in the carbon chain. So the whole of this goes, and you form your methane, sorry, your ethane, your alkane. So even here it is the same thing. So we shall form our benzene, and then to add a nitro group we shall need Cont, nitric acid, we shall need Cont, Cont sulfuric acid. Okay, and the whole of it is heated at 60 degrees Celsius. We shall form our nitrobenzene. So if I wanted to give you this, but I saw we hadn't studied it. I wanted to give you this, but we shall study it. Okay, and from this you form aniline or aminobenzene. So from this you can still take it to aminobenzene, and we shall see. Then with this we shall need to form our benzene. Same thing. Oh my god, sorry for that. Okay, and then from this we take it home. Just 2 steps, can you imagine? And what do we need? Here we shall need zinc dust. We shall need to heat this with zinc. Okay, you remove this phenol and you form the ring, and then the ring you just add chlorine, okay, in the presence of iron. You get a mixture of benzene and chlorine, okay, and then in that mixture you add there iron, and then you do some heating. We shall form our final product. And this was just simple. Just simple. Okay? So you practice these reactions that involve benzene. Practice enough, do enough. I'm going to post for you questions in the classroom. Somebody should remind me. I'm going to post for you questions that have a ring. And you do as much as you can. You write mechanisms, you write synthesis. Do as much as you can as far as benzene is concerned. It is. So let's talk about hydrogenation. And with hydrogenation, it is simple. Okay? Here we add, it is the same reaction. Reaction of benzene with hydrogen in presence of nickel catalyst heated at 150 degrees Celsius. We shall form our cyclohexane. Let me also give you another one. My God, this is too much. So let's say I have this one, okay, and I have my benzene, okay, and I react my benzene with hydrogen in presence of platinum catalyst, or in presence of palladium at room temperature, or in presence of nickel, okay, and the nickel is heated at 150 degrees Celsius. Then we shall form what? Our cyclohexane. Just now, it is as simple as this. And you can use this reaction also in organic synthesis. We shall form our cyclo. So this is cyclohexane. Okay? And this was benzene. This was benzene. For instance, I might give you such a reaction, and I want you to effect. Show me how you can prepare, how you can effect such a reaction. And I give you phenol, okay? This is OH, phenol, and I want you to convert phenol into methyl cyclohexane. Something of this kind. You wanna give it a try? So just think about it. So anyway, it is as simple. So we shall have, the first reaction is we shall form benzene. Okay, are you seeing that? Oh, sorry for that. We shall form benzene. Okay, this one is not there. And then from benzene, we convert our benzene to methyl benzene. Okay, to methyl benzene. Are you seeing? And then a methyl group here. So whether I put it here, it remains on carbon number 1. And then from this, I hydrogenate. Okay, I react it with hydrogen in presence of nickel heated at 150 degrees Celsius. Hydrogen, presence of nickel, okay, heated at 150 degrees Celsius. I shall form this. So the ring, these delocalized electrons, they get hydrogenated. Okay, this ring undergoes electrophilic addition reaction to form, or undergoes hydrogenation to form methyl cyclohexane. So before you do this, make sure you have this methyl group here. Okay, So even if they want cyclohexanol, you can prepare it from benzene, whereby on your benzene you add there the OH, and then after you hydrogenate. So there is no reason why things should, even if you want cyclo, this, oh sorry for that, from benzene, Cl, just add the Cl here and then you hydrogenate, we shall form this. So the reactions, I think these ones are just easy. We shall add CH3 Br in presence of iron 3 bromide. There is a E. We shall form our methyl benzene, and then from this we shall just add there zinc dust. Okay, and then we do the heating. So basically it is as simple as this. There is nothing hard here. There is nothing hard here. Okay? Yes. So whether it's this, whether it's OH here, whichever way, whatever you want, you can prepare it. So let's rub and proceed. So that is our reaction. And now in presence of UV light, you remember when we were introducing this, we said that if you get your benzene, okay, benzene, and you put it in the same reagent with chlorine, and you seal it, and you leave everything in darkness, okay, there is no observable change. The greenish yellow gas remains. But now when you transfer this setup, okay, to UV radiations, to sunlight, so that our benzene and chlorine, our mixture receives some sunlight, then the whole of it will react to form a colorless, the greenish yellow. The greenish yellow gas is going to disappear. Why is it disappearing? It is because the benzene with the halogen in presence of UV light, they will undergo what we call a free radical mechanism or a free radical reaction, whereby the chlorine, when exposed to sunlight, it will undergo homolytic fission to form radicals, and now the radicals, since chlorine is a bit excess, now the radicals will induce the benzene to undergo electrophilic addition reactions, okay, or to undergo addition reactions to form cyclohexane. So it is basically as simple as this, and we've covered all this. So chlorine mixed with benzene in presence of sunlight or UV rays, the benzene becomes highly substituted to form chlorine atoms. To form this, so let's write the mechanism. So not mechanism, but the reaction. So you have your benzene, and that's our benzene. Okay, okay, and the benzene is mixed with chlorine in presence of UV, ultraviolet light from the sun. Then the halogens, they will add themselves across this benzene, so that you have the Cl here, Cl here, Cl here, the same, and the same. Okay, and it's a free radical mechanism. Okay, and you can do this mechanism if you remember the other reaction. Okay, if you remember the other reaction, where maybe let's do the mechanism. You never know, but I want to do for all these. I'll just do 1 or 2 and we proceed. So this is our product, and this one is 1. So if you consider this to be carbon 1, 2, 3, 4, 5, 6. So it is 1, 2, 3, 4, 5, 6 hexachloro. There are 6 chloride and then cyclohexane. 1, 2, 3, 4, 5, 6 hexachloro cyclohexane. Let's try the mechanism. Just for the sake or for security reasons, because I might not give you the mechanism, and you open your enable paper, boom, it's number 1, and you start saying, you see, teacher didn't give us the mechanism, now see. So this is chlorine, okay, in presence of UV. So we shall have our 1, 2, 3, 4, 5, 6 hexachloro cyclohexane. So you have the Cl here, Cl here, Cl here, Cl here, Cl here, and finally Cl here. So the first thing that happens, homolytic fission, where our Cl undergoes what we call cleavage, okay, Cl to form radicals, where this will take 1 and this one also will take the remaining 1 to form the 2 chloride radicals, okay, and another radical here. So you remember this reaction in methane or in alkanes. Now the chloride radical that is formed, it is the one that will react with a benzene ring, okay, it will react with a benzene ring. So you have electrons here, and I'll do just 2 steps and you've complete. So the radical that is formed, okay, it will come and take and put its 1 electron here, and then this one also will bring 1 from the bond, and the remaining 1 will be taken up by this carbon. And so what shall we form? Sorry, this is so what shall we form? We shall form our radical of benzene. Can you imagine? So you have a dot here and a dot here and the Cl here, okay, with a radical of benzene. So you have a radical here, okay, it's a dot, not a ring. Now our benzene radical, it is the one that will now react with a neutral molecule, okay, of chlorine, where it will come, brings 1 electron, and then brings that 1 electron here, and then the other one is taken up by this chloride radical. And so what shall we form? Now we shall form, sorry for that, this is not my benzene when I'm writing with a pen, but the touchpad is soft. So you have the Cl here, and then another Cl here, and then a double bond and another bond. Then the same applies, the same reaction here, where here it will proceed and you add the Cl here until when you have substituted and you form this as your final product. I hope it is okay. I hope we have explained. But if it is not okay, then we can still proceed, okay? It doesn't stop us from completing the reaction. It is you who can instruct. Yeah, so that's basically how the reaction is easy. So let's talk about combustion, and then we call it. And this is the easiest you can ever find. All hydrocarbons, they burn in air to produce carbon dioxide and water only. And so benzene, it's not a special case, it is also a hydrocarbon. Okay, so it will burn in oxygen, excess oxygen in fact, to produce carbon dioxide and water. It's not a special case, it is also a hydrocarbon. So you have your benzene C6H6, and then burning in excess oxygen. The oxygen must be in excess, whereas if it's not excess, then you produce carbon monoxide gas. If it's limited, you produce carbon, which is not good. So we shall produce carbon dioxide, and it's a gas, and water. Okay, and this one is a liquid balance. If you put a 2 here and a 3 here and dice a 2, if you put a 6 here and a 3 here, so this is the oxygens. They are 12 here plus 3, that's 15. So we shall put 15 out of 2. So that is our equation. So if you want to balance without a 2, then you shall just multiply 2 here, 2 here, and 2 here. So you get your equation. So basically that's how simple it is. And so that's how we mark the end of our today's lesson. So please practice enough, make enough practice. The magic bullet is now practice. I've given you enough. You have enough information that you need. Now the magic bullet is practice, 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 practice. Otherwise you'll be kawa. By the time you go back to school, trust me, you'll be kawa if you practice enough.